Hello, so today we are going to differentiate a function using the first principle method. The formula for the first principle method is f of x plus h minus f of x divided by h and limits h approach to 0 or h is tending towards 0. Okay, so in the first slide I'm going to explain how we can get this function, which is the limit h tends to 0, f of x plus h minus f of x divided by h. So let's take a x-axis and a y-axis and take a function. So let's suppose this is a function and take 2 points, one here which is correspond to x. So this distance is x, and take another point which is a little bit far away from the x, and this distance is h. So if you take this total distance, it will be h plus x. Okay. Now if your input is x and the function is f of x, then this y value will become f of x, and this y value will become f of x plus h, because input for this one is your x plus h. Okay, so we know how to calculate the slope of any functions. The slope is always rise over run, right? So what is this function? If you see, it is f of x plus h, take away f of x. So I can write f of x plus h, take away f of x. And what is this distance? This distance is f of x plus h. From here to here, take away this one, it will become h. So in summary, your slope is equal to f of x plus h minus f of x divided by h. Okay, and slope, in another terms, we call the slope as a dy by dx. So change in y with respect to change in x, and that is f of x plus h minus f of x divided by h. Now this is for very far distance. Let's suppose you are taking a very small distance. Assume this a small change. Okay, so this is rise and this is run. So this h will be close to 0. Okay, so in that case we will write our dy by dx is equal to limit h tends to 0 f of x plus h minus f of x over h. So this is your first principle method. So just I have shown you how to derive the first principle methods, or it is also known as differentiation, using first principle method. Okay, so based on this formula, we are going to solve one of the previous year questions which was asked in 2022 Living Cert exams. So the function here is f of x is equal to 2x square plus 4x, and they have asked differentiate this function with by using the first principle. Okay, always if the function is given, try to find f of x plus h. So what you have to do is basically you have to replace x by x plus h. So can I write like this, x plus h square plus 4 again x plus h. Okay, so this will become, let me multiply this 2 times, okay, plus 4x plus 4h. Now this will become, if you multiply, this becomes x square plus xh plus hex h plus h square plus 4x plus 4h. Now if we multiply by 2, this becomes 2 hex h. So this will become 2x square. Now 2 hex h multiplied by 2, this will become 4 hex h plus 2h square plus 4x plus 4h. Now this is our f of x plus h, right? Now we will use the formula here. So f of h minus f of x, okay? So f of x plus h minus f of x divided by h. So what you'll get here is 2 hex square plus 4 hex h plus 2h square plus 4 hex plus 4h. Take away this, which is 2x square minus 2x square minus 4x. Sorry, this one is, let me erase this. This is 4x. Okay, so always remember, in using the first principle method, the f of x will be always cancel out. So this is cancelling out with this, and this is cancelling out with this. So what you are getting finally is 4 hex h plus 2h square plus 4h divided by h. Obviously we have limits, h tends to 0. Now you should divide by h. What you'll get? 4x plus 2h plus 4. And when you put limits, h tends to 0, this will become 4x plus 4, because this function which is given here, this will become 0 because h is 0. So this is the way you can use to differentiate any function if they ask particularly using the first principle method. Okay, so hope you understand this concept, and if you have any questions regarding this or any other topics you want to discuss, you can drop your message in the comment section. So I will see you next time.